A lot of Maths Method students struggle to answer these types of questions. Let's see how we can do it really quickly. Consider the function f where f of x is defined by this rule. Find the real values of p for which the equation f of x equals p has exactly one solution. Rearranging the equation, we can write this as f of x minus p is equal to 0. This means that we're translating the function f of x up or down p units depending on the value of p. Now what you also needed to know is this. One solution means that we want exactly one x-intercept for the function f of x once it's translated up or down p units. Now the best way to answer this question is to have a look at the graph of the function. So if we sketch this, it's going to look something like this. And what we want to do is work out the coordinates of the turning points. And so doing this, you're going to get these coordinates. Now if we translate this function up or down p units, then there's going to be two ways that we're going to have exactly one x-intercept. The first way is to translate this function down p units so the maximum value is going to be below the x-axis, and the second method is to translate this up some p units where the minimum value is going to be above the x-axis. F of x minus p translates the graph up or down p units, which is going to affect the y values. Now the y value of the maximum point is 1, and so the new point is going to be 1 minus p. Now we want this to be below the x-axis, which means that we want this new point, this new y value, to be less than 0. Rearranging to solve for the value of p, we're going to get the value of p has to be larger than 1. Doing a similar thing for the minimum y coordinate, the minimum y coordinate is 23 over 27, and minus p is going to give us the new y coordinate. Now we want this to be above the x-axis, and so we want this y value to be larger than 0. Now solving for p, we're going to get p is less than 23 over 27. And so for these p values, we're going to get f of x equals p has exactly one solution. Now, if you want to learn more transformation questions similar to this one for your exams, then check out mathsmethodsclub.com.au.